Okay, so questions.
So like problem like number 51.
Okay. All right, guys, be quiet if you're not asking the question. And right now, Lexi is. All right, 51. What about it?
Wait, not that one. I lied. I'm sorry. 52. My bad.
Okay, 52.
Yeah.
52 is actually a whole lot like 51, but my guess is it's the combination of the square root with these exponents. Okay. What I would do first of all is I would convert this and simplify that a little bit first by pulling the square root into the fraction, okay? And remember, if you have a fraction inside a square root, you can simply square root the numerator and square root the denominator. So that means we now have the natural log of the square root of x squared over the square root of y cubed, okay? Which, that's just x. And then this is y to the 3/2 power. Okay? At that point then, we would write it as natural log of x minus, and I'd pull that 3/2 out, 3/2 natural log of y. Okay? When you expand it, you should not have anything but just a single variable or a single number in the logarithm by the time you're done. And unless there's like an expression, like x minus 5 that you can't take apart. Right, but I shouldn't see a 3x or an x squared or anything like that. Okay. Yes?
And then, so like for a question like 54, would you just simplify x squared plus 1, just have x plus 1?
That one can't simplify that way, all right, because it's addition.
Oh.
All right. So if I were doing 54, what I would do, I'd do natural log of x minus
natural log of x squared plus 1 to the 1/2 power.
Yeah.
Or
X squared plus 1 to the 1/2, and then you can pull the 1/2 out in front.
Would you rather just pull it out in front than keep it there? If it's like
Yeah, you need to pull it out. Okay. And there you could stop, because this is a binomial, so you can't simplify that anymore.
So, Mr. Hickson, tomorrow at the quiz we can use a calculator for all the problems, right?
Tomorrow for the quiz, you can't use the calculator.
For all.
For all. Sure.
Last question. Number 64. No, 67.
67. Okay. All right. So we have natural log of x minus 3 natural log of x plus 1. So what I would do first is pull the 3 in, because now we're condensing. So natural log of x minus natural log of, that's going to be x plus 1.
Third power.
Good. X plus 1 to the 3rd power. Now subtraction means we divide. Natural log. Yeah, and you've got the x in the numerator, the x plus 1 cubed in the denominator. Any other questions? 75. Okay. Let me move this down a little bit. What does work? Oh yeah, 2 fingers. There we go. All right, so 75. I would work from the inside out first of all. So this 2 natural log of y plus 4 is going to be the natural log of y plus 4 squared. Okay? So the natural log of y plus that.
I was thinking like y plus 2, I put those in parentheses by accident on your.
Oh, you treated it kind of like that? Okay. Yeah. Just to finish this one out since we've got it here. Now that we have addition, I would put those together, so it's natural log of y times y plus 4 squared. And I've still got that 1/3. So good. This is the third root. Okay? The third root of y times y plus 4 squared. Then we still have this.
Could you call it the 2/3 power?
You can, as long as you have the y to the 1/3.
Yeah.
Okay? So this is what Jacob was just asking. Can we write this as y plus 4 to the 2/3? Yes, as long as we make the y to the 1/3. Okay? Either one of these would be fine. Okay? But let's not forget this last part. Since it's minus the natural log of y minus 1, we put this whole thing over y minus 1. Okay? And that's it. Okay?
Can you pull up the answers to the emails on like your website or something? Or is that
All of them? Or
kind of
like these ones you can do on your calculator, but
like those?
these
Just, like,
ones,
clarify.
well, this one's log of 10 plus log of z. And if you want to simplify that, log base 10 to 10 is 1. So you could write it as 1 plus the log of z. Okay? Here you have the log of y minus the log of 2. Here you have the log. You have negative 3 log base 6 of z. For 44, you have 1/3 natural log of t. I know I'm kind of getting out of line a little bit here. This one goes with that. Smaller there, okay. And then 46, you have the natural log of x plus the natural log of y minus the natural log of z. Okay. And then number 48, you have 3 log base 5 of x plus 3 log base 5 of y plus log of base 5 of z. Okay? And then after that, the only even we haven't done
96.
is 56 here. That's log base b. So log base b, we're going to have 1/2 log base b of x plus 4 log base b of y minus 4 log base b of z. Okay, sorry that's a little sloppy.
Oh, the square root's only over the x in that problem, not over the y as well?
Yeah, the y is to the 4th,
Okay.
so. Alright, so those are all your even answers for the first section there.
What about number 96?
96, okay. Okay, 96, the human memory model, alright? This is kind of an interesting problem. We have students participating in a psychology experiment, attended several lectures, and were given an exam. Every month for the next year, the students were retested to see how much of the material they remembered. The average scores for the group are given by the human memory model, 90 minus 15 log base 10 of t plus 1, from t going from 0 to 12, where t is the time in months. Alright, t goes from 0 to 12 because 12 months. Okay? 0 would be testing them right after they started. Okay? And then they test them every month after that. Okay? So, I'll let you do A, plug it into your calculator. What was the average score on the original exam? T equals 0. Well, think with me. The log base 10 of 1 is what?
1.
What power of 10 gives us 1? The 0 power, right? So, f of 0 is 90 minus 15 times 0, right? So the average score on the original exam was 90. Okay? The average score after 6 months, here, C and D, you're just plugging in different values of t. Okay? So evaluate it when t is 6, plug it into your calculator, and what'd you guys get? 77.3%. Okay. What about D? 73.3. Okay. Now the last one, we could solve one of two ways. Okay. Let's do it by hand first of all. When did it decrease to 75? Well, 75 would equal this, and then we're solving for t, right?
When the whole thing equals 1, log t equals 1. Needs to equal 1.
Okay, so you subtract, you get negative 15 equals negative 15 log of 10. So then I divide by the negative 15, so 1 equals the log of t plus 1. Okay? Now, we haven't talked about how to solve these really other than by rewriting it as an exponential. Okay? So our log is a base 10. So we would say 10 to the first has to equal t plus 1, right? So it was the 9th month. At the 9th month, we knew, or the average score was 75%. Okay? One thing on your calculator I wanted to show you, because this is actually a really useful thing, especially when you get into trying to solve or find when functions equal a certain thing and you don't know how to solve it algebraically. Okay? If you're allowed to use your calculator on that part, watch what you can do. I'm going to graph the original function. So minus 15 log of x plus 1. Okay? I'm also going to graph a horizontal line at the value I want it to equal. So 75. Okay? Now, I'm going to, before I actually hit graph, I'm going to set my window. X min is 0. X max is 12. The Y min we can go from 0, because that's the minimum possible on a test, to 100. Okay? So now we can see the graph of both the horizontal line and of our memory model. So how would I use that to figure out when we've reached the 75% mark.
When
You zoom in
There's
first.
gotta be something.
When they intersect, okay? Where they intersect. And you can zoom in if you want. You can do like zoom box. That might be helpful. Okay? If I do zoom box, you set it like at the bottom left corner of where you want to be. And then hit enter. And then just go to the right and go up. And hit enter again, and it'll set your window to whatever you put in that box. Okay?
And the Inspire, you can also, it gives you the 975. If you go analyze, there's 0 minimum, maximum, and intersection.
Yeah. Yeah.
Okay.
And that's what we're going to do here. If you take a look at this, now I can see where they cross. But even if I do trace, I may not get exactly where I want it to be. So that's where if you hit second calculate, second calc, we want to calculate the intersection, number 5. And here it's just like when we found zeros. You remember doing that? The zeros and the max and min points with the calculator. You have a first curve, you have the left bound, right bound, and a guess. Well, here we're dealing with 2 different equations. So it's asking you for a first curve, and that's our model up here. So I hit enter. Now it's asking for a second curve, which is the only other one we have, so it automatically switched to it. If it were something else, you could hit the up or down arrows to kind of swap through all the different graphs you have graphed. So that's my second one. And then a guess. I'm going to come over here close to where I think it is and hit enter, and it gives me my intersection 975. So I know we're going to hit the 75% mark at month 9. Okay. So I show you that just because it's kind of a neat way of solving ones that you don't know how to solve algebraically. Okay. Now that's a lot of work. You know, punching it all in, doing all that stuff, getting the windows set right. If you can do it algebraically, it might be faster, but that's a handy tool. Okay.
We're gonna have one like that in the quiz.
No.
Problem.
No, the only word problem on your quiz is going to be one involving the growth, like interest.
Oh,
Okay.
so you
And
can
for the
solve
quiz,
it.
I'm giving you the general formula. You're going to have to apply it right, but for the quiz, I'm giving you the
Sorry for
formula.
the interruption, Mr. Hickson. Could you please dismiss Samantha Susi to the 400 building?
All right,
Thank
she'll
you.
be on her way. So, are there any other questions from the homework? Nick, juice needs to go away, please. Okay? Thank you. You're allowed to have water, but not like juice and stuff. Alright. Okay, so let's look at what we have new for today. And really, we're just kind of formalizing something that we've been talking about a little bit kind of all along the way. Alright? And that is solving exponential equations. Alright? On Monday, we will look at solving logarithmic equations and some strategies related to that. But today we're going to look at solving exponentials. We're going to practice a couple, and then we're actually going to break into some teams and have a little competition. Alright, so let's see here. The first thing that we're going to do, when we have an exponential equation that we're trying to solve, so we need to recognize kind of which situation we're in. You're either going to have an exponential on both sides of your equation or an exponential just on one side of the equation. Okay? Now the second one occurs more often. But I want to address the first one because it's actually a really easy one to handle. Okay? If there are exponentials on both sides of the equation and they have the same base, then the exponents have to be equal. Okay? So, someone give me an exponential function.
4 yeah.
4 to the x, okay? So let's say I have 4 to the x. Alignments off. There we go. 4 to the x. And let's say on the other side of my equation, I have 4 to the 5x minus 1. Okay? Yeah, I've got exponentials on both sides that have a base of 4, so that means x has to equal 5x minus 1. Okay? That's not difficult, but it's easy to overlook. Alright, so that's why I pointed out here. More commonly, however, we're going to end up having an exponential that is only on one side of the equation. And if that's the case, we're going to use the inverse operation. Okay? What would the inverse operation be? For any exponential,
-1.
it's the logarithm
Base 10.
with the same base. Okay? Or some of you learned how to do it where you did the log base 10 every time no matter what, and then you used your exponent rule. That's fine if that makes sense for you. I prefer to do it this way. We're going to use the logarithm of the same base. And then we can use the change of base formula to finish, or to simplify the one side. Okay, we'll see how to do that in a couple minutes. So, here's one case. I have e to the 2x equals e to the x squared minus 8. So if I were trying to solve this equation, what would my next step look like? Nico?
Well, since you have both same bases, you can just say that 2x equals x squared minus 8.
Good. 2x equals x squared minus 8 because we have the same base. Now, why does this work? Well, let's think about it this way. If I took the natural log of both sides, which is a log base e, it would cancel out both of those. I made that minus 8 way too big. But it would cancel out both of the exponentials, leaving us on both sides just the exponent. Okay? So, that's why it works. It also works because it's just common sense. I mean, you have the same thing raised to a power. If they're equal, the powers must be equal. Okay? Yes?
I'm confused. Is the 8 part of the power?
Yes, it is. I wrote it a little big in mine. So.
Oh, it is? Oops, my bad.
Yeah, 8 is part of the power. Otherwise, we couldn't do it that way.
I did it like as a quadratic equation.
Oh,
And
yeah.
It works, but.
Yeah, this is e to the x squared minus 8 power.
Someone tell you, there's a Hello Kitty.
Yeah, someone left that in here a while ago. I don't know whose it is. Alright, now guys, at this point, you know how to solve those. Alright, we don't even need to finish it because you guys are really good at solving quadratic equations. You can either use the quadratic formula, or you can complete the square if you really like that, or you can factor. Okay? So, it's up to you. But the key on all of these is just getting to the point where we've got an equation that we're familiar with solving. Okay? Now, here we have another one. 6 to the 5x power equals 3,000. So how would I handle that one?
5x equals 1. 5x
No,
oh no.
Wait, hang on a sec. Nick, what'd you say?
Write 3,000 to 4, like 6 to the power something.
Oh, you're thinking of it more like this. If it were log base 6 of 5x equals 3,000. Then you would do 6 to the 3,000 equals 5x. That's when it's a log base 6. This is an exponential base 6. Derek, can you help us out?
Can you like make them both logs? Or,
Okay.
and you make the 5x in front and the left side.
Okay.
So it'll be log of 6 times 5x.
Okay. If you do that and then you pull the 5 out in front, 5x out in front, that's going to equal the log base 10 of 3,000. Okay. Then you divide by log of 6. Okay. And essentially what you just did is rederive the change of base formula. Okay. Because I would get the same place a little different way. If you like doing it that way, that's perfectly fine. I would have done it by right off the bat taking the log base 6 of both sides. Okay? Now, neither one of these is right or wrong, it's just a different way of thinking about it. Okay? I would do it this way. This will undo the exponential, leaving me just the exponent. And then this I would use my change of base, which is log of 3,000 over log of 6. Okay, so either way works.
I don't know if this is, but like in Miss Hilton's class, we did it where you could change the base of the exponent by like doing it to like the 4th root and then just multiplying that into the exponent. Like, you make, it doesn't work for that equation, but like, you make it 6 to the 4th power times, 6 to the power of 4 times 5x, and then you change 6 to 6 to the 4th power, and then, never mind.
Never mind.
I don't know, maybe you're just trying to force it on this one and it just isn't going to work.
Yeah,
but
it doesn't work on
there are cases where, for instance, let's say we had 2 to the 5x, and over here, and that equaled, let's say, 8.
Yeah, okay.
You could rewrite the 8 as a 2 cubed equal to 2 to the 5x, and then you've got this case again, where 5x equals 3.
We did that. No, okay.
And that works. That could be a really easy way to do it. That's, again, kind of the beauty of math, is that a lot of times, a lot of the things that we do, there's going to be a lot of different ways you could go about doing it. As long as you're just careful to follow the rules, then it'll work no matter which way you pick. Okay? Alright, so that's the basics. We've done a little bit of that. Alright. Let's see, we've got 3, 6, 9,
Is this
12,
under quiz
15.
as well?
No,
Only in the context of the one growth problem. The compound interest. But we've been doing a number of those along the way. Okay? And honestly, by the time we're done today, I could even include this and you guys will be, you'll have it down, no problem. So, alright, we've got 15, so what I want you to do is get into groups of 3, and I want you to move your desks so that you are, facing each other, okay? So go. We should have 5 groups of 3. Okay, let's go.
Oh, yes! Sorry, snooze you lose. To the web. What?
And when you get your group, think of a team name. Let's go, please. Move your desks. Get together with 2 other people.
Entire way.
And here's the deal, the winning team,
Oh, yes. Wait, what's the winning team get?
Yeah, we get that.
If we get extra credit, I'll be very happy.
Plus 5.
alright, here's the deal. The winning team will get 3 points to split evenly amongst yourselves on the quiz. You'll get a bonus point on your quiz tomorrow.
Like,
Alright.
what happened in our group, she got the 4 point on the quiz, and we can distribute the other.
No, you
One
each
point,
get
like-
one bonus point.
You mean like
I was
can we
kinda
like-
joking with you.
No, she wants to give us.
If she wants to give you her bonus point,
Yeah.
have our
Yeah.
no, you just get 1
Mr.
point.
Hickson.
So.
So if it's like out of 28, you get 26 out of 28, you get a 27 out of 28, or you
Yes.
get like you have 93.
No, you get 1 point on the quiz.
Yeah, that's actually.
So, alright, so, which actually is better than just
Yeah.
getting 1%. Alright, the only difference is if you already did 100, I just give you 101. That's, I don't give like, because if it were 1 point and it was out of 25, then it would take you up to 104%.
Yeah, yeah.
or something. So.
We got a team.
Alright, what's your team name?
With W.I.
You didn't use your initials, did you?
No. Alex. Do you see an A in there? Do you see
Yeah,
any
I'm
Y in there?
wondering what the letters mean.
Alright,
White.
alright, wonderful. Let's, what's our team name?
Team Nigo.
No, we're team. I want to be team Slytherin.
Slytherin.
The way his
I
face is.
don't know what that means. Maybe the
It's
Hufflepuff.
from Harry Potter.
Yes, I'm a Hufflepuff.
No, Team Nigo. Just put Team Nigo. Just put Team Nigo.
Just
Go on, pick one real quick.
What, one person?
There's a couple people, but like one guy who shows up.
Hey, what's your name?
I don't want to be scrubbed. Swagacy. Swagacy? That's the name we wanted. DSMS.
Eric,
DSMS.
Alexei, Jacob.
You get paper.
Alright.
Yeah.
Yeah, here we go.
Yeah.
We want to be
SB.
Paper?
S, 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 no, the letter S.
Did not hear you. Why would
Mr. Hickson, we've decided.
Slavic power.
We'll be Team Nigeria.
Team Nigeria. Alright,
China.
Team China. Alright.
Team China?
We name ourselves City
Alright. We're not taking that much time on the names, okay? So that's what you got. That's what you got to stick with. Alright, so here's the deal. I'm going to give you a problem. The first team to show me the correct answer.
Wait, do we need a calculator for this process?
First team, raise your hand if you have what you think is the correct answer, and I'll check it. Okay. But listen. If it is incorrect, you may not submit another answer until every other team has had a chance. The first team to give me the right answer gets 3 points. Second place, 2 points. Third place, 1 point. Fourth and fifth do not get any points.
Wait, what's the award? What's the award? One point.
A bonus point on your quiz tomorrow.
Ah, yeah.
I just put one
You each get 1 point. I jokingly said you'd get 3 points to split evenly amongst yourselves. To make it sound better. Alright, are y'all ready? Here you go.
Relax.
So 14.
Yep.
Are you done? No, I don't. Yash took my stuff, now I'm behind. Because he took my stuff. We're having some team issues here. Sorry, dude. Stupid. What? Yeah, when's the name? No, we can still be the team. Can you use the budget? I'm going. Alex! I'm gonna have.
No, I don't
Julio,
know.
what you doing?
I'm like the slowest one.
I think I have.
Help your team out.
Gary.
You don't have to work as 3 individuals, you can help each other.
Okay, there now it's. Yeah, I choose this.
I think we can work that three.
That's kind of the
Okay,
idea.
we got.
What you being wrong?
What's your answer?
That would suck.
That's correct.
Ah!
You're in first place.
I had it
Well,
wrong, and I
Jacob.
had it right.
What's the answer?
Well, keep going. We get second and third place too. Don't say it out loud.
So
Don't
you
answer
have
that.
to find.
Mr. Rickson, what if I don't think my answer's right?
Well, check with your teammates. That's what you have. Well, we're terrible.
I've got the answer. Sir,
Does your team agree?
do we agree? Yes.
Does your team agree?
Yeah, we said yeah.
That's correct.
Mr.
I
Rickson!
said yes.
He was the first one to have a team agreement. What do you have? That is correct. We're in third place.
Way to go, you guys tried this time. Should have taken
That is correct.
Mr. X, you made a vote here.
All right, so someone from Team Jed, come up here and tell us how you got your answer. Mr. Dixon.
So you know, we don't want to in our team. Whenever someone submits an answer, as soon as they raise their hand, the entire team agrees on it. That's a new amendment.
So you're racing amongst yourselves, as whoever happens to get it first.
Yes, because we just lost a point for no reason.
Well, you gotta agree. Team China got 2 points.
9 points.
All right, so what do we do
They're
here?
just sitting there coloring.
All right, listen up, please. Julio, if you do not participate, you will not get any credit.
Okay.
All right, listen up to Derek, please.
First you solve this, and then you get.
First step is just solve the problem, right?
Something like that. You put like
The rest of you be quiet, please.
log keys. And you just divide by this.
Loving the voice. So easy.
And then you just divide by 3.
3 questions.
Okay.
Only 7 minutes left. Okay, so 3 max.
Okay. And then, like he said, you're dividing by
Just divide
3.
by 3. You do it in your calculator and you get T equals to.
I'm not sure of that.
I don't know, like, what's the exact number?
0.4997.
Point
0.4 what?
Just put 0.49. Just round it to the
Yeah,
nearest.
that'll be fine.
All right, good, good. And guys, if you get a long decimal like that, if it's a less than 1, don't round it all the way to 0.4, okay? If it's 0 point something, but 0.409, that would be fine, okay? But good. All right, so our next problem, are you ready?
I'm ready. Let's go.
All right, here we go.
Ah, we're going.
Everyone just does it on their calculator. Go by that.
Okay.
Grab that nice. We agreed, right guys?
That's correct.
We agreed.
That's incorrect.
Yay.
Oh,
I'd like to know how.
Shut up, guys.
Yeah.
Here.
You guys have it?
Wait, I didn't get that.
That is correct.
Oh, it's a lot.
Okay, I did not.
I got it, I got it.
Yeah.
Mr. Rickson.
Good looking.
No, sorry. That is correct. Alright, so Team Nigeria scores a point. Okay, here we go. Someone else want to give the answer? Alright, Jacob? Alright, so listen to how this goes.
So first you divide by 1,000. And then you take the natural log of each side, so the natural log of b cancels, so you get negative 4x equals the natural log of 3 over 40.
Hey guys, 3 over 40 is just 75,000 reduced.
Yeah. And then you divide by negative 4 and you get, I don't remember the number. Well, you do the natural log, and then you divide by negative 4, and it's...
And team, can you help them out?
4756.
7, 5, 6.
Okay. Good.
How many problems are in total?
So 0.6475, so on. So if you did 648, that would be fine. Okay.
Problems?
As many as we can get in here. So we got 4 more minutes.
Yeah.
All right. So one more. Here we go. Next problem.
Double or nothing?
Oh my gosh.
Wait, there's one more.
Oh.
We would need 6 points.
Yep.
I have Jacob.
You guys have it?
Wait.
What? No, we know we can't win.
Is it
so-
6?
So what?
Is it
You have a
6?
quiz tomorrow.
Answer 6.
No, the answer's not 6.
Well, you got
Looks
it
like we
wrong.
have to wait.
201.28.
No. Don't yell out the answer, please, because there is second and third place.
Someone get it?
201.29.
I got a random thought, it's probably wrong.
What?
My thing
That-
broke.
That is correct.
Yeah,
Good.
No!
Team China.
Okay, guys.
Oh, Team Nigeria got that one.
Yash, could you please get it right?
Wait.
Still they don't.
No clue, I'm trying.
Let's
Let's go Team China!
Team China!
哦，他是计算器
It's up to Team SP.
Shock the world! Come from behind!
Guys over there.
Guys, just someone get it, and they lose.
Yes, yes.
No, they tie.
Oh.
Wanna try it?
Yeah, if 2 other teams get it,
Please don't let Jacob win.
Team China will be in the
I
lead.
don't want Jacob to win. I'm still ahead of them like crazy class, because that did not change. I did pick Jacob.
Alright. You got an answer?
I did it the other way.
I think so.
So
Well,
close.
we picked him.
So close.
Oh, very nice. Very good.
Yeah, I know, but.
You regret it?
Oh,
No regret.
you missed one little thing.
Oh, that's why I got it.
You wanna try it?
Yeah, if you want.
Okay, we'll try it.
Please be wrong.
That is correct.
No!
Oh, we have to do it.
Okay, so
Okay.
1 plus.
That's not good.
I just did the
I quit.
My only incentive is
Did you guys figure it out?
next question.
I don't think I did it the right way, but
Alright.
Okay, no points.
Hey, what's the first thing we could do here?
Multiply both sides by
Bye.
You can multiply both sides by the denominator, or take the reciprocal of both sides.
you did.
Yeah.
That would get it in the numerator.
That did. Maybe that did work.
Yes.
I think you might have screwed up.
Somewhere with the calculator. 'cause
Equals
I think that's
275. Then multiply by 525,
Wait.
subtract 1, take the natural log. Listen, please. What you guys did, you guys were right all the way to the end, except this is a negative x. You had negative 0.09, it should have been positive 0.09. Okay? X, positive 0.0953, and so on. Alright, good job. See ya.
Ah! We need one more question.